Okay, so this video is going to be a quick video on an application of hyperbolas. So this is following up from the algebraic hyperbola video we just did, where we looked over the definition, wrote the equation of it, practiced some problems just algebraically. Now we're looking at some applications. So the applications of this come out of really hyperbolas and ellipses. The conic section stuff came out a lot from astronomy when people were looking at the solar system and trying to figure out planetary orbits, star orbits, comets, and orbits usually work either hyperbolically or elliptically, and so that's where the ellipses and hyperbolas came out of this. On Earth, we kind of use it to think about sound waves and distances from that. So this is an example of how you would use it. We have an explosion that's recorded by two microphones that are 2 miles apart. Right, so if I think about, I have two microphones 2 miles apart, and there's an explosion that happens. Right, so this is my explosion, and I have my microphone 1 and my microphone 2. Microphone 1, which is M1, received the sounds 4 seconds before the second microphone, M2. Which means the explosion is closer to M1 than it is to M2, because if microphone 1 heard it 4 seconds before, it has to be closer to that one. We know that sound travels at 1100 feet per second. We want to know where this explosion could be. So when we draw this, we have the situation, we want to put it on a coordinate system to write equations for it. And when we're writing equations, we want to minimize how much complexity we have. So we're going to try to center this at the origin, which means this is going to be on the x-axis, and the y-axis is exactly in the center. And so if I think about the distance here, this needs to be 1 mile, this needs to be the second mile. Since I have this in 1100 feet, I'm going to change this to feet as well. So this is 5,280 feet. This is negative 5,280. I know that microphone 1 is 4 seconds closer to the explosion than microphone 2 is based on the speed of sound. So if I know that it's 4 seconds closer, and I know that sound is 1100 feet per second, then I know that it's 4,400 feet closer, which means the distance from M1 to E is 4,400 feet closer than the distance from M2 to E. So E to M2 minus E to M1 is 4,400. So if I look at this, I know this is a hyperbola situation because I have two fixed points, these microphones, and the distance from a point to each of those fixed points, when I subtract them, I have some value. That leads me to the hyperbola definition that's talking about differences. Right, so I can place this on a hyperbola that I know that this explosion could happen anywhere on this branch. So now I just need to figure out the equation of this. So let's try to find the equation. I know the center is 0, 0, based on how I set this up. And so H and K are 0. And I know that the A value, right, if this is horizontally facing, this is up to there. I can figure that out. So how do I figure out the A value? Well, I know that this difference of distances is 4,400. If I transfer this to any hyperbola, right, so if I think about a hyperbola going like this, any point to its focuses should have that difference in distance. So if I take this point, right, the vertex, and measure its distance to that focus, and then I take this focus and measure its distance. So I'm taking this vertex and looking at the distances. Well, this is 2A, and then this is the remaining bits from vertex to focus on either side. When I subtract these distances, those are going to go away, that extra bit, which means the only thing left over is the 2A, because that and that will cancel out when I subtract. So that distance that's constant is the 2A length. So I know that 2a is 4,400, which means a is 2,200. I know this is horizontal, so x squared comes first, over 2,200 squared, minus y squared over b squared equals 1. So then I look at trying to find b squared. Well, I know c is 5,280. So I can use c squared equals a squared plus b squared. So 5,280 squared equals 2,200 squared plus b squared. And you get that b squared is 23,038,400. So we can write that down. 2,200 squared, that's 4,840,000. And then b squared is 23,038,400 equals 1. So the explosion happens. It has to be on the right side of this because it has to be closer to the microphone 1. So it's on this side. It's not on that side because then microphone 2 would have heard it before microphone 1 heard it. So it's on the right branch of this equation, this hyperbola. So there's a lot to do with the definition, that 2a value on this problem. The actual writing of it shouldn't take too long. It's going to be a big number, but the main thing to look at is that difference in distance is the same as 2a. That's the big idea here to be able to solve these application problems. That's the most common thing that's going to come up in these applications. Hopefully that was helpful. There's some examples in your textbook that also do a problem like this, and there's some problems in the problem sets as well that will have problems like this.